everyone, welcome. This is our episode club. So if you haven't been here before, we had a bunch of new followers this week, which is awesome and exciting, and I'm thrilled that everyone's here. And essentially what we do is I have a patron page. You can find that in the links down below. And part of what the patron perks are voting on episodes that we're going to break down and discuss the science behind. Hi, Timmy Jack. This week, we decided to talk about the science behind All Good Things and Emissary. Now, I clumped these together because I'd watched them recently, and then it ran away with a vote, and then I went, oh man, I watched these recently. And I didn't take science notes, so I'm gonna watch these again for the second time in 2 weeks. But it's fine, because they're good episodes, and I have no problem with that. So I'm super excited. We have to end in an hour. You have to end in an hour. Like I said, I appreciate people who are dropping in here. If you were planning on the scheduled time, we did have to push it forward by half an hour because we got things to do. And yeah, it's going to be great. So yeah, I mean, it's a beginning and an end. But we're going to start with the end. We're going to start with All Good Things. So let's break down the science behind the Star Trek Next Generation episode, All Good Things. Very funny, Billy. Very clever. All right. So, I mean, this kicks off. As far as finales go, it's brilliant. I love it. I think that it's storytelling-wise fabulous. Time travel-wise, also fabulous. It's pretty brilliant. Hey, Mikhail. So basically we find out that Picard is jumping through time. He's like, I think I might have been dreaming. I'm not sure. I don't think I was dreaming. It was very vivid. I could smell, I could taste things. And then we see him as an old man. And there's some really interesting discussions. So he ends up having Irumodic syndrome, which they explain is the deterioration of the synaptic pathways. And it's impossible to detect early on, but that I think what did she say? Like a swollen frontal lobe can possibly result in Irumodic syndrome. And this is the same disease he has in Picard, right? Correct me if I'm wrong. I didn't triple check it. So I'm like 95% sure that it's the same thing in here. And thank you, Type. I appreciate that. I just needed some community validation that I definitely had the right thing. Okay, so we're 100% sure that's the exact same thing that he has. But it's really interesting because we're jumping around 3 points in time. We have the current time. Hey, Andrew. We have our current time that we know and love, the next gen that we've been following for the last 7 years. We have the beginning, 7 years prior, before we met the crew when they were kind of already doing their thing. We met them at the beginning stages in those rough uniforms, perfectly honest. Those are not... It'd be hard for anyone to pull those uniforms off. But Tasha Yar does a great job of it. So we have the before time, we have the current time, and then we have the after time. Old man Picard time. We can, if you want to watch like an actual analysis of this episode, Samantha and I analyzed it a couple weeks ago from a fan standpoint. But to break down the science here, there's a lot of technobabble. Some of it is biology, squishy things. Hey, Benny. That I can't speak much to. I've looked up a little bit, but I think it's mostly just this sounds vaguely medical. There's not a whole lot of there. But then there's also the time travel aspect, which we can definitely start to break down, and the Devron anomaly, which we are definitely going to get into here. So, let's first talk about the squishy things. We'll talk about Picard and his disease and how they're able to medically detect that he's shifting through time, which I really, really like. So we've established that the Irumodic syndrome can show up later in life. It can't necessarily be detected. There can be some biological indicators that could make you predisposed to it. Exactly, Dave. It can make you predisposed to this disease, but it doesn't say that you necessarily definitely have it. This is one that's kind of personal to myself, not because I have Irumodic syndrome or have a swelling of the frontal lobe or anything like that, but I have a genetic family history of a disease called Barrett's esophagus, and it's one of these that doesn't manifest itself until it's in your 40s. And so they're like, well, we can test for it, can't do anything about it, so we'll test for it when you're in your 40s, because that's when it's going to matter. So there are diseases like that, at least one, at least one that I know of. And obviously, you know, we have a lot of other degenerative diseases, dementia, Alzheimer's, and those that obviously don't manifest themselves, and we don't have any indicator that, yes, you're definitely going to have that as well. And that's kind of more along the lines of what Picard is dealing with. Again, they don't really go into a ton of detail, even though they're describing it specifically here. Also, hi Andy, I didn't see you drop in the chat. For engrams. Okay, so we have the Irumodic syndrome can only exist in the later timeline because that's how the disease manifests. Okay. A cool thing was that I don't think is scientific at all, but Beverly Crusher does a scan of Picard, and then 2 minutes later she does a scan after he's had one of these blips. And she basically says she scanned his temporal lobe and says that the acetylcholine of the hippocampus has indicated that he now has 2 days worth of memories formed in the few minutes since she last scanned him. I think that is hot nonsense, but it's hot nonsense. I like it. It's great. Yeah, Type, that's a great one. I love it. Now I'm going to bed. Oh yeah, the memory engrams that memory and engrams must be manifesting themselves as acetylcholine in the temporal lobe of the hippocampus. Sure. Is where you store your memory engrams. And yes, future science. But, I mean, we did see they were consistent in it, because when he first starts having these time travel things, he's jumping all over the place, and he's not retaining any memory. He's like, I think I lived somewhere, but I don't remember it. And then his jumping becomes more common, and he's retaining the memories. Excellent. Yes, Andy, one step ahead of me. That was the other one that I really, really liked, too. She scans that, thank you, Billy. There's a 13% increase in the acetylcholine of the hippocampus. 2 days worth of memories. And that's okay. No, it was perfect. So, sorry, I've got my notes up here now for the first time. So, yeah, so she also does a scan of him and finds that there are oxygen, and I'm putting it all together, so it's not a direct quote, Billy, but thanks. She basically analyzes that his oxygen isotope ratios are consistent with someone who's been breathing the ship's air for a couple weeks, which I love. Even when I wasn't rewatching this for the science, when I was just watching it a couple weeks ago, I actually was like, that's awesome. That's awesome. That's the idea that obviously they have artificial air on this spaceship that has a certain percentage distribution, and that you'd be able to analyze basically the oxygen in someone's body and figure out the ratios of different chemicals in there and say, yeah, you've been breathing this air for at least an indeterminate amount of time, but you haven't been breathing Earth air. They would have to be very specific of the composition of the air, but it's a controlled environment, so they would be. You know, we know exactly what the proportions are I don't know off the top of my head, but on the International Space Station, we know what the ratios of oxygen to nitrogen and all of those are. Again, I don't, but someone does. And I would say, Daib, in terms of how far they can take that would probably be one of those things like, well, we don't find anything that's out of the ordinary. We're seeing proportions in your blood or your lungs or your exhalation or inhalation or whatever that, swishy things, that are consistent. Oh, thanks for the follow, Shedhead. That are consistent with the ship's oxygen. So I think it's more of a process of elimination. We're not finding something that's not part of that. So that's a good question, though, how long they be able to spread that out. Andy, I think there might be something unique to the Enterprise. I think it's probably just the ratio. Although you might be able to say that, okay, a Constitution class ship is gonna, of the a Starfleet Constitution class ship will have this ratio, because it's different, different size, different population. Those things would affect how much air and how much proportions of air you would put into all of it. And Daib, maybe they can tell the location a person lived by the chemical composition. That's really interesting. I don't know how... Galaxy class, sorry. That was the original Enterprise. Was it the original Enterprise was Constitution class? Yeah. No, you're right. Galaxy class. I knew that because every time I say the word Galaxy class, I almost say Galaxy Quest. Every single time. So I appreciate the correction. That was a good correction. All right. Yeah, so let's say we terraform Mars. Or maybe we don't terraform Mars, but we set up a base station on Mars. Kids are able to be born, grow up, live there their whole lives. With their chemical composition resulting from the air that they breathe be different than someone here on Earth. Would you be able to tell that it was different? I don't see why not. That said, I am not a biologist. I haven't taken a biology class in a very, very long time, and I've tried to look this stuff up, and I didn't come up with anything definitive. So if anyone does have any insight, I would be curious to hear any of those. Also, let me see. So we talked about it being... Oh, Andy, screen is not blinking on Xbox, but okay, so if your screen... Because mine looks fine. So if other people want to weigh in, that's fine too. Yeah, Benny, so archaeologists do that with the food. That's what I'm thinking. I'm also thinking, like, we can carbon date things based on, the amount of, oh God, how does carbon dating work again? The amount of carbon-14 decay, I think is right. The half-life of carbon-14. I think that was right. To try to figure out, even older than that, how long things have been around. Yeah, got it right. Score. So I would say that that's something similar. I just don't know how much, like, the proportion of nitrogen to oxygen to carbon dioxide to everything else that I'm breathing in gets manifested through my body. But I love that that's a thing they put in this Star Trek episode. Even if it can't scientifically be done today, I would say that's something that's not unreasonable to have in the future. The temporal lobe expansion... Probably a little bit less likely. So, okay. Oh, Kurobachi, yay! Thank you. And thank you, Domestic. So yeah. And, Daib comparing accents. Yeah, exactly. I know, where's Muhammad when we need them? Sorry, I'm getting caught up on the chat here. Composition of people's teeth. I like that. That's a cool thing, too. So if we're talking about future science, things like the replicator, yeah, agree. I love it. That's awesome. Does oxygen have an isotope that is breathable? I would say no. No. Yeah, exactly, FS Roosta. It sounds believable, even to scientists. And as a scientist, I'm watching it and I'm like, that's cool. Because I think that is cool. It's a really neat way that she can just be like, you definitely haven't been off the ship, at least in the last couple days. Even though you've formed memories in the last minute, you have not left the ship because of the composition of the atmosphere that you've been breathing. I love that. I think that's brilliant. And we can tell if you've been to Earth, for example, because you would have high concentrations of nitrogen. So it's not like you're being portaled through a wormhole. Process of elimination in Star Trek universe. There's a lot of options that could be happening. Yeah, and oxygen-3 isn't. No, that's a molecule. That's not an isotope. Isotopes are when you have... Oh, Tanya, thank you. Isotopes are when you have higher neutrons. Higher amount of neutrons. Protons are what make the molecule, or the atom. Protons are what make the atom. Neutrons are what make the isotopes. But a lot of carbon is, and you can make carbon-14 because air supplies are replicated. Yeah, that's fair. Awesome. Ooh, Mikhail, that's cool. I think you can see oxygen and other gases in the hair. That would make sense. I like that idea, too. All good thoughts. Smart people. I like this. This is why we have this discussion. Okay, any other squishy things that were said that we have to break down into this? Oh, good. I'm so glad you found it too. Here, I can throw, if there's some new people here in the chat, I'll just throw this in here. So people know who's talking to them. All right. So we have the oxygen isotope ratios. again, oxygen isotopes aren't really a thing that we found. But that works. Oh, Mohammed, thank you. Also, hi. With the timing of the origin of life. The goo that you brought. Yeah, so let's jump ahead then to what's staying on the theme of biology and things definitely out of my depth. And Daib asked a good question here. Does carbon dating work for non-carbon based life forms? Would it only work on Earth, or would it work? So carbon-14, the half-life of carbon-14 is a property of the carbon itself. I think how effective it would be based on the amount of carbon-14 on other planets would make it either easier or difficult, but the half-life is the same. So if you found an abundance of carbon-14, you just wouldn't be able to actually date it, because would you be able to? Yeah. You don't know what the original percentage is. So, yeah, I think that works. So you would just be, the ratios would be off. You'd have to have some other information, but that's a really, really good question. I like that. So yeah, Q is causing havoc. Q is being Q. He's just Q. Yeah, good. Takes Picard to the origin of life. He's like, welcome home, people. This is where you began. And it says 3.5 billion years prior, give or take a couple eons, in France for some reason, where we are primordial goo. That's what everyone says. And that dating is correct. Because again, remember, we're on space-time. Like, literally, we're on space-time. And time in astronomy is, give or take a couple eons, makes perfect sense. And even though we're in the year, 23 something versus 2000 something now, 2020 now, that few hundred years, blip on astronomy's radar. So even though Star Trek takes place in the future, the 3.5 billion years ago stays fine, whether it's now or in Star Trek land that we're doing. Yeah, it's funny that he places it in France because it's Picard and he's messing with Picard is how I saw that. Paciferal said you might be able to find a silicon dating method or silicon-based life form. That would be kind of cool. But yeah, I mean, Daib said too, we need the baseline, and all of the Q stuff. Yeah, so good thoughts. You'd have to be able to check the current carbon-14 generation. I like that. So you can, it's just an extra step that we have to do, like when we recalculated that. I like that. That's awesome. Cool. All right, let's get into the hot time travel nonsense. All right, that's most of the biology stuff here. Thank you, Mohammed. I'll let you carry on the silicon-based dating system there. Silicon-based dating system. Sounds like something you'd find at Quarks. All right. They find a temporal anomaly. Good old anomaly. He's jumping through time. This admiral pops up, as they are wont to do, and says, we're detecting a spatial anomaly in the Devron system near the neutral zone. Go check it out. Starfleet is going there to find it. So Kurabachi, this is in the current time. And for people who've drifted in and out of the chat, there are 3 timelines that are taking place during All Good Things. We have the old Picard current timeline, which is like the finale of Next Generation, which is the timeline that we've been following through all of them in. And then we have the before times, the pre-TNG timeline. And so they are in the current TNG timeline. They get told, go investigate the spatial anomaly in the spatial anomaly, not analogy, anomaly in the Devron system near the Romulan neutral zone. Don't cross over the neutral zone. All right. Now, they get there. They think it might be a temporal anomaly. Picard's starting to jump back and forth here. They're doing continuous subspace sweeps to try to detect a temporal distortion. Picard is now trying to find these. He is in the past, the before time, and he gets told, go, because there's a space, you were supposed to go to Farpoint, which is where the, pilot of TNG kicks off. You're supposed to go to Farpoint, go to the Devron system to investigate a spatial anomaly. And he's like, aha, there's an anomaly taking place in the Devron system in 2 places, in 2 different times. So that's not, there might be something to this. Brad. Thank you, Benny, 2370. So I think we can establish that Q is just interfering. As Andy asked, would he have broken space-time if Q hadn't interfered? Q is just interfering left and right. He's causing all of this stuff. FS Rusta asked, is this an Einstein-Rosen bridge? Not really. I'm thinking through that. That was the face that I made. No. An Einstein-Rosen bridge is technically a wormhole that is connecting 2 points. Okay. I'm changing my answer. Possibly. Let's think about world lines. And if you've taken special relativity or any kind of senior level astrophysics classes and I said world lines and you cried a little bit, just go pour yourself a drink. It'll be fine. So let's think about Andy, thanks. Let's think about space-time, but let's just think about an X and Y graph. Okay. Let's think about an X and Y graph. Remember in school when you have an X equals 3, that for all of Y, X equals 3. It's a vertical line that intersects with X equals 3. And I know I'm doing this backwards because it's mirrored, but if I try to do it for you, I will leave. So let's say X equals 3. That's a single line. I'm proposing, and I'm doing this real time right now, that if instead we have space and we have time. So our 3 dimensions in space, because we can't conceptualize 4 dimensions, let's just imagine all 3 dimensions of space are down here. We have a single dimension of time, and this is how you do it in space-time, in special relativity. This is how you deal with space-time and world lines. Space is here, time is here. The Devron anomaly, I'm doing this real time, I haven't figured this out. The Devron anomaly does this. Okay. No. That's a lie. The Devron anomaly does this. The Devron anomaly exists in the same space in all time. So it's our X equals 3. It's at all points in time, they're finding the Devron anomaly at the same place. Does that work? And it's expanding. So it's expanding in space as we go back in time. So I wish I'm gonna draw this and then I'm gonna show it. Can I? I don't think I can draw it mirrored. We're gonna sort of draw it. Okay. So I never do this. So the anomaly is kind of a constant. I've exaggerated its expansion. But I think this works. So this is going to be X, this is going to be time. And again, it's mirrored, so I don't think it's going to work. Where, I can't believe I'm doing this. This is space. The Devron anomaly starts here and it expands back in time. Does this work? Yes. Devron equals 3. So yeah, it's exactly, we have the mirror universe. Yeah, no, it is right. Okay. So yeah, this is the point, this is where the Devron system is. The Devron system is here in space. In time, this anomaly happened, and then it started to expand in space and time as it worked its way back. I think it works. Yeah, it's visual, it's mirrored. It's mirrored so you can read it. Like you can read this. Whatever. I haven't had enough caffeine. It's been a day, everyone. It's been a day. All right. I think it works. So, yeah, Billy, we'll get to anti-time. So Andy, exactly. So we've drawn, as we do in this chat, we've drawn the graph for how the Devron anomaly works. And, that it's, because remember, it's getting bigger. It's taking up more space, even though it's still exaggerated on this graph. It's still just a sliver in the same space, but it's slightly getting bigger, and it's going backwards in time. So, you're not wrong, Andrew, about the time travel theory of quantum leap. Okay, so there's a lot in the chat. Listen, you all are hilarious and awesome, and I love every single one of you. Okay, the before time. Yeah, that's what we talk about. All right. Yeah, I was way back in there. All right, if there's any extra questions that we need here, Asdelin, pull out your Penrose diagrams. That's what we're here for. So, okay, I think we got it. There's the high five. Thank you, Andy. That's how the Devron anomaly works. It started at a point later in time and expanded backwards. The cool thing that I like is that we have Picard loves his tachyon beams. I will just say that. Picard uses tachyon beams more than anyone else I've seen in the Star Trek universe. It's how he's trying to detect cloaked Romulan ships, is like, build a network of tachyon beams. So this is to build an anti-tachyon beam and fire it at the anomaly. So, yeah, F. Rooster. Oh, sorry. I didn't actually answer. Is that a thank you for reminding me, the Einstein-Rosen bridge. It got buried in the chat. I don't think it is. I don't think it is because it's existing throughout time. An Einstein-Rosen bridge connects 2 points in space-time and does that. Folds them over each other so you can go between them, so you can tunnel between them. This, I think, is just an anomaly that's existing throughout space and time, but in a very particular way. I think that's what it is. You're not going to travel through it to go to different points in space-time. It just exists throughout space and time. Can I say... I'll say space-time one more time. All right. Yeah, so... So going forward in time, Devron is collapsing. Yes, Stray Robotics. The Devron anomaly is getting smaller, and they actually realized that it was like 6 hours old in the after times, the old Picard times, that they were studying there. And Asdelin asking about how does it expand backwards. That's, I think, what we're gonna get into now. So it was collapsing, and X-Panther kind of summarized, collapsing into time while existing in the same localized space, but because of our experience, it was larger in the past. Yes, that is correct. That's how I'm thinking about it. Okay, so everyone has it here. I think I'm all caught up. Okay, so the anti-tachyon beam thing. They're like, we have to study this anomaly first. And yeah, I think someone asked in the chat, this is Data's idea, was to basically probe it to see what's going on. Did I write down the dialogue for this? Let me see. Yeah, so we're going to use an inverse tachyon pulse to scan the inside of the barrier here. So, oh lord, there's a lot of stuff here. So we're in the old Picard time. Thank you, Billy. We're in the old Picard time where this anomaly is 6 hours old, and they're realizing it's an eruption of anti-time. Don't ask any more questions than that with respect to how it formed. We don't know how it formed. We suspect Q had something to do with it. He probably did. And has and is an expansion of anti-time. Because of that, it's expanding backwards through time, because reasons. But from the inverse tachyon pulse, Picard is making it worse. And so let's talk about time and anti-time. And, Shedhead asked like a really deep question. I'm going to copy this and paste it into my notes. Because I just scanned it. It's a really good question, but I need to come back to it. Okay. I'm not going to let it give up because it's brilliant. All right. Anti-time. They basically say, and we have matter and antimatter. Matter and antimatter are real things. Matter is obviously everything that we're seeing and touching and all that fun stuff. That's matter. antimatter does exist. We have antiparticles. If you break down to our fundamental particles, protons, neutrons, and electrons, we have antiprotons. We have positrons, which are anti-electrons. And basically what happens is that when they meet, that's the matter and antimatter, when they meet, they obliterate. Exactly how they describe it in this episode. They say when matter and antimatter meet, oh, thanks for the follow. They annihilate each other, and in real life, they basically turn into light. It emits high energy photons when matter and antimatter meet. So if I always had this visual from my professor, if Bender and anti-Bender shook hands, think of Flexo as anti-Bender. Technically, when they shook hands, they should have annihilated into light. That's just always been the visual in my head for matter and antimatter. So, so those are real things. Then they bring in this idea of anti-time. They've discovered that this temporal anomaly in the Devron system is an explosion of anti-time. And when time and anti-time meet, they annihilate themselves. This is hard. This is because we don't have... It's not impossible, but using matter as an analogy for time are like such left field ideas. Now, Andy brings up a good point that Star Trek has used a time particle before, the chronoton. They have pulled this out for time travel. And so if they're saying that maybe there's an anti-chronoton out there, that's what the Devron anomaly is. It's an explosion of anti-chronotons. We're just making the technobabble worse. If it's anti-chronotons, then it's expanding backwards in time because it's anti-time, so it flows naturally, as in the same way you have protons have a positive charge. Can't believe I'm doing this. Electrons have a negative charge. Chronotons, fictional, have a positive flow through time. Anti-chronotons have a negative flow through time. Even that, it doesn't work. It doesn't really work because antimatter doesn't change charge. It's a different thing. Let's just say, forget the matter-antimatter analogy. We're going to use the charge analogy, right? And say as a flow through time. Normal chronotons that are made up and we're using for the purpose of this episode flow in a positive way, progress 1 second per second. Anti-chronotons, anti-time, progress minus 1 second per second. Oh, that's funny. I do have a green stripe on my shirt. Thank you. I'm glad that I've so lost the plot that now people are just distracted by my clothing. So, and F Roost is like, I'm not even going to start to analyze the spin of the chronoton. That's awesome. Okay. So, Enterprise, Billy, exactly. I'll get to the wave and particle duality of chronotons in a second. So, the anti-tachyon beam. Okay. Space-time, when there's mass, if you're drinking, get ready. If you have a bowling ball and a trampoline, it's going to bend mass, it's going to bend space-time down like this. That's what normal mass does. Tachyons are a theoretical particle that invert space-time. They're anti-mass, basically. I think that's where they got this idea. Because if you think about, you can think about it, people are divided. I've got into like Reddit battles and then I basically just decided that it wasn't worth my time to argue with people on the internet. Who'd have thought that whether it's imaginary matter or inverse matter, whatever, it inverts space-time. And so I think where they're trying to go is if you have an inverse tachyon, technically that's just normal matter. That's just normal matter. Thanks, everyone. I like how Andy's just putting his dream emotes into the thing. One day we'll have a drink emote. So the inverse tachyon beam is essentially meant to be a beam of anti-time. Anti-space-time. Anti-inverted space-time. Now I've gone cross-eyed. So, yeah, exactly, Andrew. Yes, Atma, and actually I have whole videos about it. You can see I wrote the episode of Extra Credits about Element Zero in Mass Effect, so you can go check that out. Yeah. Let's take a step back. The anomaly itself is an explosion of anti-time. Okay. Brad, how dare you? And I agree, Efrusta, and this is why people on the internet start fights. Because it's a liberal use of the inverse of inverse. Where saying inverse in a mathematical sense is a very strict thing. If you have taken abstract algebra, which I frankly barely passed, abstract algebra is not my jam, but that's going back to fundamental mathematical principles that basically say you have a number set, and that number set is going to follow a set of rules, one of them being an inverse, that if you perform an operation on this set, it has an inverse such that you create a null number. Don't even. That's as most as I'm ever going to repeat about abstract. At least something stuck, but it just makes me angry when I talk about it. So we have anti-time here, and then we have an inverse tachyon beam. And tachyons are already either imaginary or, let's say they're imaginary mass, for the sake of argument. Now we're using three different but distinct ways of describing mathematical constructs, which is how we're having to live right now. So inverse, anti, and imaginary are all not the same thing, but we're having to use them fairly interchangeably to solve our way out of this pickle. Which is the best way that we can talk about it. Panther, agree. Did you have the yellow one? The yellow abstract algebra book that was like that thick and yet weighed on my soul more than any other textbook? Because I hate that thing. So, we have an explosion of anti-time. To investigate it, Picard and Data have chosen to probe it with an inverse tachyon pulse. Thank you, I'm so close. I feel like I'm so close. We're probing it with an inverse tachyon pulse. So, okay. Different book, same pain. The inverse tachyon pulse, let's say that instead of thinking about tachyons like this, we're saying we're doing something else with the tachyons, such that we're not creating normal matter. We instead have more like anti-tachyons at this point. And because tachyons distort space-time opposite to how normal mass does. Because tachyons distort space-time opposite to what normal mass does, when we use the invert of that, we're distorting space-time backwards, which is anti-time. I think I ran out of that explanation super fast. Thank you, Andy. I appreciate the free pass on this one. I like that. Yeah, Asimov has some great fun with time moments. The Bahana asked, what about a regular tachyon pulse, and what would that do to this? That's a good question. Let's think about that for a second. So we have antichronotons here that naturally flow backwards in time. If we took a regular tachyon pulse, where tachyons constantly move faster than the speed of light, and invert normal space-time, that wouldn't necessarily push the flow in the opposite direction. So a normal tachyon beam, if we're talking about the way that it plays with space-time, would still be treating the flow of time normally. When you have tachyons on our world lines, they still flow as in cause and effect. You know, something happens, then something happens. Now that stuff happens faster than the speed of light, which is what tachyons are. but it doesn't invert the flow of time. So I think normal tachyons would do it. Let's say that anti-tachyons are like anti-chronotons. They always go faster than the speed of light, but they flow backwards. And thank you for the host, Rocket Sage. I think that works. I feel like I needed to write that down because I definitely reasoned myself into a place I will never find again. But at least we recorded this for posterity. So normal tachyons still experience time in a normal direction. Inverse tachyons experience time in a backwards direction in the same time that anti-time flows. They don't need to be the same thing, but they experience time properly. So we'll go with that. So when they're probing with an anti-tachyon beam, an inverse tachyon beam, they are pushing that flow of time faster. And because tachyons exist in both space and time, they're expanding it. That makes sense to me. Yeah, Andrew, we'll start just doing AMAs sometimes. It's brilliant. We still have another episode to get to, but thankfully it's not as heady as this, so I think we're going to be okay. I didn't even go into the fact that when they say that when time and anti-time annihilate themselves, they rupture space. Let's not worry about that. Thank you, Taib. I appreciate it. Okay. Fun with time. This is my Sheldon show. Fun with flags. This is fun with time. Dr. Aaron's fun with time. And at the end of the day, it's because Q. Exactly. I agree, Mikhail. I think we're making sense of it, even though, as Brad said, we've fallen down a rabbit hole. It's not... And, okay, Andrew, exactly. We're now just bringing up Q. And, to be fair, all of this, and I can't gesture wildly enough, all of this is exactly what Q says at the end of the episode. Open your mind, accept the paradox that there are unknown possibilities of existence. Boom. Okay, Q. This was our human trial. We have been forced to open our minds to accept this nonsense paradox and accept the unknown possibilities of existence. For one anti-moment. Now, okay, the pause that I want to give right here before we get into the next episode, and then I'll answer a couple questions that we have. Really interesting point here is, and for the single solitary moment, Picard accepted it, which is how they passed the test, which I hope is how all of you are now passing Q's test right here, to say, we accept this nonsense temporal anomaly that had happened, that it can exist, and that has opened our minds, and we have passed the test for now. Because knowing Q, the test is never over. But remember, Picard comes back and tells everyone what has happened in the future. And they're like, thanks a lot, Picard. Way to violate the temporal directive, and now we're going to have a bunch of those idiots coming to yell at us right now. I think that... they say very explicitly at the beginning that because the anomaly didn't occur, the timeline has already been changed. Because the Devron anomaly did exist in the future, that timeline hasn't changed, which is a good cop-out for Picard. Not saying that they necessarily need one, but the fact, so we have the disease that he still has, the Irumodic syndrome, that's still carried through the timeline. But his relationship with Beverly... Deanna's relationship with Worf, whatever the hell that was, and the subsequent fallout with Riker, the fact that Jonathan Frakes has aged much more gracefully than the Devron anomaly Jonathan Frakes is proof in itself that the timeline doesn't hold. We'll just say that. That works. Awesome. Domestic, thank you. Good times. I am drinking. I did use the trampoline analogy a couple times, so fair enough. Drinks are allowed at this point. Drinks are, if you imbibe, then by all means feel free, because I'm wishing I had one right now. But Q was brilliant. Q is brilliant in this, and it super works. And we didn't even get into the whole static warp shell idea with the barrier to time and anti-time. I think, frankly, I'm fine with all of that because warp bubbles are essentially bubbles through... Yeah, they're just bubbles in space-time that push into subspace. So you can basically create a barrier between whatever flow of time, as we've discussed how time and anti-time work, creating just like a, you know, like a big ass bubble on each point that just stops that flow. Sure, I'm okay with that. That works. All right, it's that pizza oven, exactly. Atma Prime, that's brilliant. This just goes to show eating pizza will have you look like that versus that. That's excellent. Yeah, so it is just basically these bubbles that block that anomaly from going through. I will say again, I've plugged this before. If you haven't played the card game Chrono Trek, try to find it. I love it. But part of the game in it is the Devron anomaly expands, and that's like your timeline, that if the Devron anomaly punches through time backwards far enough to 3.5 billion years ago, then Q wins the game. Which is great. I love it. But I won't go into the details of it. It's just a great game, and I love thinking about it every single time I hear the Devron anomaly. Okay, and Asdalin, I see your question as well that I will put on pause so I can briefly, as promised, talk about Emissary. So, let's talk about Emissary real quick, and then I'll get to the questions. I don't think we're not gonna get as deep. Honestly, thank God we're talking about Emissary next. If we were having a whole other episode like this, we'd be in trouble. We could have clearly done the whole episode on all good things. Battle of Wolf 359. Wolf 359 is an actual star system that we actually got to see parallax from Wolf 359 recently. We did not see a Borg battle going on, so on that one. We have Bahana. That's the only thing that I have to really gripe with in this episode. So we have I love it. I love it. Cheers to Andy and Benny for both saying the exact same thing, and thank you for the follow, Tumor Boy. Okay, we discover a wormhole. The thing that's unique about this wormhole in Deep Space Nine is that it's stable. It connects the Alpha Quadrant to the Gamma Quadrant across 70,000 light years. And the 2 points are fixed. If you're a Mass Effect fan, think of these as two mass relays. We've connected 2 points in space-time that are stapled together, and we can transverse it. So, incredibly rare, not something we've commonly seen, and certainly something not big enough such that ships can actually travel through it. Now, Billy, okay, to clarify for everyone, that Borg cube that hit all of the clickbait headlines was a gap in the data that is a square pixel. I mean, that said, has anyone heard from Hugh lately? Because he might have left. Alright. Yeah, exactly, Atma Prime. They created this then. Now, I have headcanoned the Prophets before, and I don't actually think I've talked about them on this show. I've talked about it on other podcasts that I've been interviewed on, but I did just want to take a quick second to talk about the Prophets and how I think that they do actually work brilliantly. Let's talk about wormholes again real quick. We had some great questions earlier. Trying to find the username again. Sorry. You know, me and names do not work very well together. But FS Rusta asked about the Einstein-Rosen bridge and how if this anomaly could be one of those. And I said no, in the sense that it's not connecting a tunnel between 2 points in space and time. This is just an anomaly that exists throughout time at a fixed location in space. I don't want to talk about the different anomaly anymore until I answer the question. But wormholes are Einstein-Rosen bridges. Effectively the same thing. There are franchises that use them slightly differently, but if we think about them as just connecting 2 points in space and time, we can think about this tunnel. Now, let's imagine, and I'm just going to use this piece of paper again, but let's imagine basically we have a point in space and time here. We have a point in space and time here. We want to bend it over and then build a tunnel that goes through it. And the way that I'm imaging this is very specific right now, because the way, here we go. The way that I talk about wormholes as being a punch through vertically through those 2 points in space and time is how I think about the prophets. When we use these analogies for wormholes, we talk about space-time being bent however we want. I always use the analogy of toilet paper. I actually have a perfect example of this right here. All right. So we have space-time. We bend it over, and then we punch a hole straight through it. That's our wormhole. This is the alpha quadrant to the gamma quadrant. Wormhole punched right through. Now, time is existing linearly in the horizontal direction here. What I'm proposing is that when you have a wormhole, particularly one that is punching through to the gamma quadrant, it is going through vertically. And if we think about our world lines and we think about our space-time diagram, you could have, this is what made me think about it. You could have it such that the time component of the Bajoran wormhole exists perpendicular to our normal space-time. So if you have time in the wormhole, time outside of the wormhole like this, then it's not unreasonable to say that the prophets or the wormhole aliens or whatever you want to call them exist outside of our understanding of time. I'm quite proud of this because it makes sense to me how we can have this. I think that it does actually work. Now, oh, Atma, thank you. Yeah, I actually have Event Horizon. I had Event Horizon, but no one, I don't want to say no one voted for it. Patrons did vote for it, but I think everyone just has those flashbacks of it being a terrifying movie. So we haven't proposed it for the episode club yet. So the Bahana asked, can the prophets access fluidic space? And fluidic space and subspace in Star Trek are kind of used interchangeably. They're this idea that they're outside of space-time. Now, when I'm talking about the prophets within the wormhole, that wormhole still is within, technically within, our own space-time. Their dimensions are just slightly askew to ours, but they still exist within space-time because they're through this tunnel, this Einstein-Rosen bridge. It's just you go through, basically you go through a, whatever it's called, coordinate transformation. You go through a coordinate transformation when you go into the wormhole, but you don't necessarily leave space-time. So, while I would argue they don't have access to subspace inherently in the same way that we in Starfleet don't have access to subspace, there's nothing stopping them from punching through it. I just think that they don't, as someone else brought up in the chat, Species 8472 they exist in subspace. They exist in subspace. They occasionally punch through into normal space. I would say the prophets exist in normal space just through a coordinate transformation in their wormhole. I hope people agree with me. I haven't been watching the chat. All right. Thank you. And, yeah. Asdelin, I didn't know that fact about Event Horizon. I'm not sure I needed to know that fact. Okay, Atma, the examples early on, and then we could stop the movie. I like that. Oh, cool, Andrew. There's a Star Trek Online story with Q, the prophets in multidimensional Ansleys. Yeah. Ah, X-Panther, I love that analogy. Like your intestinal tract, it's technically outside, but it's a closed system. I like that. That's awesome. I really, really like that. All right, people seem to be following, so I think that we're good. And yeah, Bahana, we'll just say that in these caves, there's also a spatial anomaly that results in a coordinate transformation such that you exist in the same plane as the prophets. That works. Domestic. Whatever. I will still argue that, but that's fine. But you're wrong. Okay, so the last thing I want to talk about with Emissary. So that was the prophets. The other thing with Emissary is that they are 116 million kilometers to the wormhole. They say it's going to take a couple of months to get there because they only have 6 functional thrusters. Kira says that's unacceptable. It has to be done in a day. So their solution, as mentioned in the chat, they have to lower the inertial mass of the station using the deflector array. Oh. So inertial mass is your mass. Your inertial mass is basically how hard it is to start moving, to change. Remember, inertia is the desire for an object to stay moving or not moving, to stay in its own state, is inertia. You have to apply a force to change a body's inertia. How much it resists that force has to do with its inertial mass, how heavy it is, what its shape is, all of that fun stuff. So changing the lowering the inertial mass of the station to make it easier to move, to get up to a speed, makes sense if you just look at the words. You lower the inertial mass of the station using the deflector array to get somewhere faster than you would normally because your engines aren't fast enough. I'm good with that. How you actually lower the inertial mass of a station? Okay, but we're in Star Trek land, so we're gonna slightly do this. Yeah, mass is hard to get around. We could have been slightly better with a warp shell. Again, yeah. We can kind of make this work because we live in a Star Trek universe where tachyons are a thing. Which are technically, like, if we talk about tachyons, that they invert space-time. So if you're able, I would rather their explanation be, we are going, we'll pull a Picard. Picard's not far off. He was just here. So let's call Picard and the Enterprise and see if they can push using an inverse tachyon beam. Did we solve it? That's how I would do it. It doesn't even have to be an inverse tachyon beam. Let's just make a tachyon beam from the Enterprise using Picard. That will allow the station to coast on the tachyons that are going faster than the speed of light. That I guess would reduce the effect. Okay, so here's the word that they should have used. They could reduce the effective inertial mass. That's the key there. You can say, how much does this station appear to be taking up? And we can reduce that because we live in Star Trek universe and we have things like warp drives and inertial dampeners and all that stuff. So what you're saying is you can reduce the effective, or I'm using kind of an engineering term, but you can reduce the apparent mass of the space station, which would reduce its dip in space-time, which would allow it to get to the wormhole faster. Thank you, Ryak. I think that kind of works. So, let me see. That's funny. All right. Throw all the books off the station. Also, all the out-of-date fanfictions from Garrick's shop, and that will lighten the station. Yeah. It just jettison everything out. Well, the thing is, too, we're in space, so action, reaction. So if you throw things off all in the same direction, that will increase your thrust, which will allow you to get to the station faster. But, yeah, if you're trying to cut down your trip from months to within a day, you're going to have to reduce the apparent mass of the space station, which you can do through things and reasons, because we live in a Star Trek universe. All right. So, in that respect, couple quick questions. So Terrell Kirkman asked on Twitter if have to gather. That's true, Theron. That's a good point. And yeah, Benny, from a story point in Deep Space Nine, we cannot let Picard save the day. I agree. And thank you, Mikhail. I really appreciate it. We also got a follow from Master Tech at the same time. So, yay. You all are great. All right. So Terrell Kirkman asked on Twitter, we're going back to All Good Things. Picard's using technobabble in 3 separate timelines or dimensions here. How can they intersect? I think we solved that with our space-time diagram, so I'm kind of good with that. And then if an anti-time rip gets larger in the past, why did our old... Okay, we answered Terrell's question, so yay. Then the other question, and I did not save the usernames, so I apologize for this. Is there a reason time is still perceived as one-dimensional? So we could actually see it as a winding path. Okay, no worries. I like tangential questions. I think this is great. So why is time perceived as one-dimensional is a great question. part of it's because that's how, if we think about the spatial dimensions we can move in and experience, we only have evidence that time progresses in a single dimension, because we've never experienced time. We've never been able to go back in time. We've never experienced time sitting on top of itself. And the reason I like your question is because I think in All Good Things, what it is showing you is exactly what your question's asking, is that maybe if you're warping time such that you have an anomaly that exists in multiple points in time, maybe it's not one-dimensional. Maybe we have to think about it as two-dimensional, where you can go in X or you can go in Y. You can do some of this, some of that. Sorry for that earworm. I haven't heard that one in a long time. But we think about it, and so treating it as one-dimensional doesn't necessarily limit it from being looped over itself. It just means that you experience it, and it's really going down to the 1 second per second. That per second is the way we experience time. It's not, we experience time as a river, a network of tributaries. I like that. And it's really, it's how we perceive time versus how we can experimentally observe time. So from a scientific standpoint, we can only observe time progressing at 1 second per second. From our puny brains only comprehending 4% of the entire known universe standpoint, the question about time starts to become a little nebulous. And Andrew brought up, religions thinking about way we experience time, or this idea of tributaries, and all of that is valid. I mean, even myself, and I've said this on this chat before, I'll have those dreams where I'll go back to sleep and 40 real minutes pass, and I've dreamt like a day's worth of events happening that I feel like I've experienced, that I've gone through. And so that makes you wonder about time. My favorite ever, and I think if Benny's still in the chat, if he can find it, or any of the other, I think there might be some VIPs. Yeah, Andy, you might be able to throw a link in there too. The Jeremy Bearimy from The Good Place. Jeremy Bearimy explanation is one of my favorites of all time for how we experience time. But again, if you think of it as one line, we can still say that's a single dimension. Whether it wraps on top of itself or exists in two planes, we still only experience that on the line itself, even though it goes into and out of other dimensions. We only experience it on the line itself. It's like the flatland we were talking about last week, right? You're in two dimensions. You can't, even though there is a third dimension, you just can't see it. That's how I would talk about time. There might be more dimensions to time. We only experience one dimension in time. I think that helps. And thank you for the link. Yeah. Tumor Boy. What's the dot over the I? It's a Thursday. It's so good. It's so good. So definitely check that video out. Oh, God. And I'm over time. I need to get going soon. But we had a final question here. So if time is just an emergent phenomenon from a near infinite sequences of instantaneous events, does that mean time is relative differences in length of those sequences and the comparison of memories of those events? I would say that's similar to kind of what I was just saying, that we experience time within one dimension, but that's not saying it doesn't go into and out of other dimensions, like Jeremy Bearimy. And it was not an intentional pun, actually, because it is 4:33 my time, and I'm supposed to... the premiere for Lower Decks is starting soon. Sorry. I'm going to go watch the premiere. So I'm really glad. And yeah, I'm glad it was your favorite episode club so far. Star Trek Lower Decks, which premieres for everyone on Thursday. But we have the virtual Hollywood premiere. So that's a thing. I know. Sorry. And now suddenly I'm enemies with everyone for right reasons. You should be angry. And yeah. All right. But definitely, I mean, I can't plug Lower Decks enough. I love this show, and it's fabulous. I am going to make myself Romulan whiskey because my head freaking hurts. But honestly, that was one of the most fun times I've had. I had no idea this Devron anomaly was going to be that deep. And that got deep. That was really, really fun. So thank you again. I appreciate this. And please do pass it on. And I appreciate the drink suggestions. And I'm glad, Shedhead. Yeah, that's I'm glad we ended up in the same place with that analogy. So thank you all so much. I will suggest, I don't know if it's still going on. Let me see. Yes, so there's a D&D group. One of my friends, Eliza Pearl, there's a special D&D thing going on with BuzzFeed Multiplayer that I'm going to send you all to check out. It has a ton of people watching it right now. But go say hi to Eliza for me. I don't know if she'll see it, but definitely have fun. And thank you all. You can just kind of catch the end of theirs. I don't know how much longer they'll be going for, but I'm sure it'll be fabulous. And thank you so much. You can find my links down below. Until next time. All right. Have a good one, everyone. I'll send you